So we are going to start right here with number 1. Okay. In a rhombus, ABCD, with side lengths 3, diagonals AC and BD meet at point E. If the measure of angle DAB is 46, find the length of E to B. Okay, so this is going to involve more than one picture. Because first I got to draw my rhombus and then my triangle out of that rhombus. So I'm going to draw the rhombus right on top. Rhombus means all 4 sides are congruent, right? And we're going to label it A, B, C, and D. And then we're going to draw in the diagonals. We've got A to C and B to D, and they meet at point E. Okay, it's telling me angle D, A, B, this angle right here, is 46 degrees. And it wants me to find the length of E to B. Okay, so what's half of 46 degrees, guys? 23. Why am I cutting it in half? I just want this triangle that I'm coloring in right here. So I'm going to redo that triangle. Okay, I've got A, B, E. Okay, I know A to B, because that's the outside, is 3. I know this angle right here, this is 46, so half of that makes this 23. And I want to find that length right there. Okay, we know that the diagonals of a rhombus meet at 90 degrees. So that's how I can get to here. Okay. All right, now we're just going to label it. This is my opposite and hypotenuse. So what am I going to use, guys? If I've got SOHCAHTOA, I'm going to use what? Sine. Sine of my angle equals my opposite over hypotenuse. So sine of 23 equals what? What goes on top? X or 3? What goes on the bottom? Now what do? Multiply both sides by 3, and then I plug in my calculator. 3 sine 23 equals X. So X equals, I get 1.17. Questions, comments, concerns? We're ready to try the next one then? Okay, number 2. Ophelia Payne is walking into her office building when she knows is 150 feet tall. The angle to the top of her building from her current location is 6 degrees. How much further does she need to walk? Okay, we know an office building with the ground makes a 90-degree angle, right? So this is my office building right here, all right? From her current location to the top of the building is 6 degrees. We know the building is 150 feet tall. How much further does she have to walk? Okay, what are we going to label 150? Opposite, adjacent, or hypotenuse? What are we going to label X? Okay, so what are we going to use? Sine, cosine, or tangent? Yep. So we're going to say tan of the angle equals opposite over adjacent. So I'm going to say tan of what? 6 equals opposite over adjacent, right? 150 over x, yeah. Then I'm going to multiply both sides by x. And I get x tan 6 equals 150. Then I'm going to do what next? Divide both sides by tan 6. So I go 150 divided by tan 6, and I get x is 1,427.158. The next one I'm going to read aloud, and I want you to try to draw your picture. Okay? At a point 200 feet from the base of a building, the angle of elevation to the bottom of the smokestack is 35 degrees. And the angle of elevation to the top is 53 degrees. Find the height of the smokestack. This is a harder one. Because I have two angles. What do you think that's going to look like? Think about what that's going to look like. If you're working in pencil, it's probably best. If you're working in pen, know that you might have to adjust your picture. You should try it. You should be trying these next Wednesday when we have your quiz. You're going to have to do it on your own. Okay. So, I've got a building, and I know on top of that building is a smokestack. Okay? 200 feet from the base of my building to the bottom of the smokestack, I've got 35 degrees. Okay? And then from the top of my smokestack, the whole thing, that's 53 degrees. I want to know how tall is my smokestack. Okay, because I want to know this over here. Well, I'm going to call this whole thing Y. And just the building, X. And what I'm going to do is I'm going to take Y and I'm going to subtract X from. I'm going to find the height of the building and the height of the building with the smokestack. Then I'm going to take the height of the building with the smokestack and minus the building. And that's going to give me the height of the smokestack. Okay, so let's use my pen here as kind of the building and the top is the smokestack. So I'm going to find the height of my whole pen, and then I'm going to find the height of the pen without the cap, and I'm going to subtract it to find the height of the cap. Does that make sense? Okay? I can't really do my smokestack just by itself, right? Because this doesn't, do you see this like weird triangle right in here? That's not a right triangle. So I can't use trig unless I take the whole thing minus part of it, and that gives me my smokestack. Okay? So we're going to have to do two things. We know this is the adjacent, and we know this is the opposite. We're going to find y first. Okay? So I've got opposite and adjacent, which means I'm going to use which ones? Sine, cosine, or tangent? Tangent. So I'm going to say the tan of 53 equals the building and the smokestack over the distance to the building, 200. Okay? Now I'm going to find just the building. So instead of using 53, I'm going to use 35. So I'm going to say tan of 35 equals x, that's my building, over 200. And then I'm going to have this minus that. So I'm going to say 200 tan 53 equals y. So I put that in my calculator, 200 tan 53, and I get 265.4 feet equals the building with the smokestack. Then I'm going to get 200 tan 35 equals x. This is just going to be the building. Which is going to give me 140.04 feet. And then I'm just going to subtract them, right? I'm just going to take 265.4 minus 140.04. And I'm going to get the smokestack is 125.36 feet tall. Do you guys see how useful that is? Do you want to go to the top of a 140-foot building and then try to put a ladder up there and measure a smokestack? I mean, it's probably really windy. You probably don't have a 125-foot ladder to be able to take measuring tape and measure it, you know what I'm saying? So this would be way more useful. Okay, number 4 is very similar to number 3. A communications tower is built on top of a building with the following specifications. From a point 200 meters from the base of the building, the angle of elevation to the top of the building is 23.6 degrees. And the angle of elevation to the top of the tower is 15.9 degrees. Find the height of the tower. So try to draw that picture. It's very similar to our last one. We're still 200 feet away. We know we've got a tower with something on top of it, right? And we know our angle of elevation to the top of the building is 23.6, and the angle of elevation to the top of the tower is 15.9. Give me a rough idea, guys. If you're working in pen, be able to cross it out. Pencil, you can always erase. All right, let's draw this picture. Miss Murphy speaking. Sure. What lunch does he have? Great. There's nothing colder. All right. 4. We've got a building that is 200 feet away. Okay. We've got a tower on top of it. The angle to the top of the building is, what does it say? 23.6. And then the angle to the top of the tower is 15.9. Okay? So we're going to do it very similar again. This whole thing is y. This is x. Okay? We're going to do the same thing we're going to do tan again. We have to subtract. but I have to add together my two angles in this case. Oh, no. This whole thing is 23.6, so I don't have to add them together. Okay, so I'm going to do tan of 23.6 equals my opposite, which is y, over adjacent, which is 200. So I go opposite, which is y, over adjacent, which is 200. And then I'm going to go tan of 15.9 equals opposite x over adjacent, which is 200. So I'm going to go 200 tan 23.6 equals y. Put that in my calculator, 200 tan 23.6, and I get 87.4, I'm just going to round up, equals y. And over here I'm going to go 200 tan 15.9 equals x. So I've got 200 tan 15.9 gives me 56.9 equals x. So then I'm just going to subtract again. I'm going to go 87.4 minus 56.9. That's going to be the height of my tower. 87.4 minus 56.9 is 30.5 feet. Okay, let's look at this next one. From the foot of the building, which is 150 meters from a tree, I have to look upward at an angle of 22 degrees to sight the top of the tree. From the top of the building, I have to look down at an angle of depression of 50 degrees to look at the top of the tree. How tall is the tree? How tall is the building? Okay. Let's try to do this one. Do you guys want to draw it together? Yeah, it's got that weird thing, angle of depression in there. So let's work on this together. From the foot of the building, so here's my building. To the tree is 150 meters. Okay? I have to look upward in an angle of 22 degrees to see the top of my tree. So I have to look upward to see the top of my tree. 22 degrees. From the top of the building, I have to look down. Oh, no, that's not where that goes. So I have to look up 22 degrees to find my tree. From the top of the building, I have to look down at an angle of depression, my building is bigger, of 50 degrees to see my tree. All right, let's ignore finding the height of the building first. Let's find the height of the tree. Okay, so I've just got this angle then. I can do this 22 degrees, 150 meters. I'm looking for my tree. What is this going to be? Opposite or adjacent or hypotenuse? So it says I have to look upward at an angle of 22 degrees to sight the top of my tree. I'm assuming I'm standing on the ground because I'm at the foot of a building. So I'm right here. I look up, angle of 22 degrees, trying to find the height of my tree, which is 150 meters away. Okay, is x opposite, adjacent, or hypotenuse? X is opposite. 150 is? So I'm going to use which trig function? So I'm going to say tan of 22 equals x over 150. Then what am I going to do? Not divide, but multiply 150 on both sides. 150 tan 22 equals x. So I stick it in my calculator and I get x equals, what do we get, guys? What? 60.6 meters. All right, let's try to figure out this other part. From the top of the building, I have to look down at an angle of depression 50 degrees to look at the top of the tree. So here's my building, here's my tree. We're still 150 feet away, but I need to look at an angle of depression of 50 degrees to see the top of my tree. Okay, so do you guys kind of see this picture? It's just a little bit small. Okay, so angle of depression means how much I look down, right? So that's why I'm looking down. I say we find this right here, that height, and whatever it is, we add it to our tree, and that's the height of our building. Does that make sense? So we know this height right here is the difference between our tree and our building. So once we find that, we can add it to the tree, and that's the height of our building. Okay? So again, I'm going to call this opposite and this adjacent. So I'm going to say tan of 50 equals the opposite y over the adjacent 150. And I'm going to put 150 tan 50 equals y. So 150 tan 50 gives me 178.8. But I want to add 60.6 to it to find the total height. No, because we wouldn't, because remember I have to add on this part. Because I didn't find the height of the building. I found the difference, I found the height above the tree to make up what the building is. So that's why I have to add them together. So I get my building is 239.4 feet tall. Okay, we leave in like 3 minutes. So if you want to, I would rather you guys put your calculators away and just set up your triangles. That's what you spend your time doing.